Okay, Oak Rovers, this is going to be a video to help you with worksheet number 50. And in worksheet number 50, you're going to be solving word problems that involve ages. Now, just like before, there's a series of steps that you're going to do for these problems. The first step is define the variables and draw pictures. The second step is to write the equation. And then the third step is to solve the equation. Now, in each of the problems that I have on worksheet number 50 that I'm doing, I'm going to get it to the point where you have a two-step equation where I have variables on both sides. I will have gotten rid of all the distribution properties, so all you're going to have to do is just solve an equation where you have variables on both sides. Let's look at number 1. So I'm going to be doing 1 and 6. Number 1 says Andy is twice as old as Katie. In 6 years, their ages will total 60. How old is each now? So in these types of problems, I like to make a table. So my tables are going to have how old each are now, and then how old each are going to be in 6 years. So let's look at now first. Andy's twice as old as Katie, so I let Katie be x. And then Andy will be 2x. Now in 6 years, Andy's going to be 2x plus 6, and Katie's going to be just x plus 6. So I have both a table I've kind of made now, and then in 6 years. Now it says in 6 years their ages will total 60. So what I have to do is I have to add 2x plus 6 and x plus 6 and have that equal to 60. So I've done that right here. 2x plus 6 and x plus 6 is equal to 60. Then I can combine my like terms and I get 3x plus 12 is equal to 60, and I can solve the problem from there. And actually this problem, I just have one variable on the left hand side of the equation, and I don't have variables on both sides of the equation. Now let's look at number 6. Number 6 says Tom is 4 years older than Jerry. 9 years ago, Tom was 5 times as old as Jerry. So again, I'm going to make a table. I'm going to use now and 9 years ago. So my table now looks like this. Tom is 4 years older than Jerry, so I let Jerry be x, and that makes Tom x plus 4. Okay? Now my next time I'm going to look at is 9 years ago. So that would be like now minus 9. So I'm going to look at this. 9 years ago is going to be Tom was x plus 4 now, and then minus 9, which is what he is 9 years ago. So the total, if I combine my like terms of positive 4 and minus 9, is going to be x minus 5. Jerry starts out at x, and 9 years ago, he's just going to be x minus 9. Now, let's see if I can solve this problem. Since Jerry is younger than Tom, what I'm going to have to do is multiply his age by 5 to get Tom's age. So if I do that, I'm going to have 5 times x minus 9, which is Jerry's age, and that's going to be equal to Tom's age, which is x plus 5. Now it's important in these problems that you multiply whoever is the youngest one by the amount of times they are younger than the older one. So since Tom is 5 times older, I'm going to multiply Jerry's age by 5, and that should be equal to Tom's. I always multiply the younger one by the number to get the older one. Now if you use my distributive property on the left-hand side of the equation, I should get 5x minus 45 is equal to x minus 5. And from here, you just have an equation with variables on both sides. And that is something you should be able to solve at this time. If you have any questions, stop in tomorrow morning and make sure to ask so I can help you out with these.